All right, let's dive in. We're about to tackle a subject that, let's be honest, gets a pretty bad rap: statistics. But I'm going to let you in on a little secret. It's one of the most powerful skills you can possibly have. And no, don't worry, this isn't going to be some dry, boring math class. We're here to figure out why statistics is basically the key to making sense of our, incredibly complex world. Let's get started.
So let's just get the big question out of the way first, because I'm sure it's on your mind. The textbook we're drawing from for this, OpenStack's Introductory Statistics, it asks this exact question on page 1. And you know what? It's a totally fair question. The answer, as we're about to see, is, well, pretty much everywhere.
The simple truth is, we are all surrounded by data. It's constantly coming at us from our phones, from the news, from our jobs. And without the right skills, it can really feel like you're just drowning in a sea of numbers and claims. But what if? What if you had a way to make sense of it all?
I mean, just look at this list. This is why this matters to you. We see this stuff everywhere, every single day. You turn on the news, you see a political poll? Yep, that's statistics. Watching sports and they're breaking down an athlete's performance? You guessed it, statistics. Trying to understand a medical study? Decide if it's a good time to buy a house? Or even just trying to manage your own budget? It all, and I mean all of it, boils down to being able to understand and interpret data.
And that's exactly why we're framing this whole thing not as some scary math class, but as your life raft in this sea of data. It's a practical tool. It's a way of thinking critically and making the best possible educated guess when you just don't have all the facts. It's about turning all that noise into actual knowledge.
So what is it officially? It's the science of data. But it's really a complete process, right? It starts with how we gather information, then how we analyze it to find patterns, then how we figure out what those patterns actually mean, and finally how we show those findings to other people. It's a full-cycle toolkit for understanding the world.
Generally, you can think of statistics as having two main branches. First up is descriptive statistics. This is probably what pops into your head first. Using charts, graphs, and averages to make a huge pile of data easy to digest. Then you've got inferential statistics, and this is where it gets really, really cool. This is the art of taking a small piece of data and using it to make a really smart, educated guess about a much, much bigger picture.
Now, to do any of that, we need to speak the language. So, let's start stocking our toolkit with a few absolutely essential terms. Getting these down is, for sure, the most important first step.
First up, population. Now in statistics, this doesn't just mean people. It's the entire group we want to know something about. It could be all the cars made by one company, every single star in our galaxy, or all college students in the entire country. It's the who or the what that we're ultimately interested in, the whole shebang.
Okay, but studying an entire population is usually impossible, right? Can you imagine trying to poll every single voter in a country? No way. So what we do is we take a sample. A sample is just a small, manageable piece of that bigger population. And the whole point is that we study this small sample to get information and insights about the entire population it came from. Kind of like tasting a spoonful of soup to figure out what the whole pot tastes like.
So how does this all fit together? Well, this slide lays out the basic game plan perfectly. First, you figure out your population of interest. Then you grab a representative sample from it. Step 3, you analyze that sample and get some kind of result. And finally, this is the magic part, you infer what that result probably means for the whole population. That's the core of how statistics works, right there.
And this brings us to a super important distinction. The parameter is the true value we want to know about the population, like the real, true average height of all men in a country. But we can almost never know that number for sure. What we can know is this statistic. That's a value we calculate from our sample, like the average height of the 500 guys we actually measured. So the goal is for our statistic to be a really, really good estimate of that true parameter.
Okay, that was a lot of theory. Let's make it super concrete with this example. Imagine we're doing a study on the GPA of recent college grads. The population? That's every single student who graduated last year. The sample? Well, that's just the smaller group we randomly picked for our study. Now the parameter, that's the golden number, the true average GPA of all the graduates, the thing we really want to know. And the statistic, that's the number we can actually calculate, the average GPA from our little sample group. The variable is what we're measuring for each person, so one student's GPA. And the data, well, that's the raw numbers themselves, the 3.65, the 2.80, and so on. See how all those pieces fit together to paint a picture?
So we've got the basic language down now, but where are we going with all of this? What can you actually do once you've mastered these fundamentals?
This is just the beginning.
Pretty soon, you'll be able to tackle probability, you'll understand the famous bell curve, and you'll even be able to use something called hypothesis testing to scientifically test claims. You'll be able to figure out if two things are actually related, like, say, ice cream sales and hot weather, using regression. Every single one of these concepts is just another powerful tool for making sense of the world.
Because ultimately, this isn't about passing a class or learning formulas. It's about developing a completely new lens, a new way to see the world around you more clearly, and honestly, more critically.
And I really want to leave you with this key idea, which comes straight from the source material. Don't get lost in the calculations. Seriously, a computer can do the calculations. The important part, the human part, the understanding, the insight, the story, that has to come from you. The goal is to understand what the data is trying to tell you.
So the real question is this. Now that you're starting to build up this statistical toolkit, what questions are you going to ask? What claims will you investigate? What story, hidden in the numbers that are all around us, will you be the one to uncover?